antiderivatives in 3 minutes. Let's start. So if you have any integral like this, then you should always ask yourself what function you could take the derivative of with respect to x in this case to obtain y as a result. So you want to find the so-called antiderivative. Let's look at this example. So if we have this integral, then one possible solution would be x cubed. Now don't celebrate too early, because this is not the only answer, since it could also be x cubed plus 5. Due to the derivative of x cubed plus 5 being 3x squared. So what should we do in this case? Just rewrite it as x cubed plus c, where c is a constant. So just any number you can think of. As a rule of thumb, you can use this formula to get the antiderivative. So if we have this integral, then we would get 1/2 x to the power of 4. Okay, let's try some examples. Now go ahead and try these problems. Feel free to pause the video and write the solution into the comments. So what about the first one? If you want to solve this integral, then you need to rewrite this as the integral of x to the power of minus 2 dx. Now we can use the power rule to get the following. So at the end we just get minus x to the power of minus 1 plus c. If you already tried to solve the second example, then you might came across a problem, because we can't use the power rule there, since then we would get an invalid answer. So what did mathematicians do? They thought, you know what, let's just make the natural log the antiderivative of x to the power of minus 1. Yeah, they basically did something similar with imaginary numbers, but you get to that in college. If you have a definite integral, then you probably want to know the area under a curve. In order to get that, we use the following formula. The c cancels out during subtraction, that's why we don't write it anymore as in before. You just evaluate the antiderivative with respect to the upper limit, minus the antiderivative with respect to the lower limit. So let's say our integral goes from 1 to 2 and we have the function 6x squared. So the antiderivative is just 2x cubed. So if we plug in the limits, we get 2 times 2 cubed minus 2 times 1 cubed, which is basically just 14. Alright, let's do another example, shall we? Okay, now we have x to the power of 1/2. So what should we do? Well, according to the power rule, we would get x to the power of 1/2 plus 1 divided by 1/2 plus 1, which is x to the power of 3 over 2 divided by 3 over 2. Now to get rid of a fraction in the denominator, we use the reciprocal of it. If you want to know how you can rewrite fractions as exponents into roots, then you can watch my video about derivatives. I placed timestamps there so you can immediately skip to the part. Anyways. So we have 2 times 6 cubed divided by 3 minus 2 times 3 cubed divided by 3, which is 144 minus 18, and that is 126. Now let's do an example with parentheses. So one way to solve this would be to use the binomial formulas. I hated them in school, because I just couldn't remember them. Anyways. So 2x plus 2 squared is really just 2x plus 2 times 2x plus 2. And that's just 4x squared plus 4x plus 4x plus 4. Yeah, I should make the animations faster next time. So let's rewrite this integral. Now it's way easier to form the antiderivative. It's just 4x cubed divided by 3 plus 8x squared divided by 2 plus 4x. If we now plug in the limits and do some work, then we get 256 divided by 3. Alright, one last integral. So here we have cosine of theta. The derivative of sine is equal to cosine, so the antiderivative of cosine is sine. If we now plug in the limits, we get the square root of 3 divided by 2 minus 1/2. Which is approximately 0.4. If you want to know how I converted the sine 60 and sine 30 into numbers, then you can just watch my video about trig functions. Click on it.